All right, the final lesson for this week is a review about scaling. You might remember from the previous lesson when we scaled up tanks and so forth, volume, capacity, all that stuff. Yeah, same type of stuff here. And that's the neat thing about math. It all hangs together. You learn it once and it's good no matter how you apply it. All right? And so in this case, we're simply talking about looking at scaling a little bit differently as a ratio, all right? So we talk about the ratio of the lengths of when you're dealing with a scale factor, all right? So don't let the word ratio mess you up. If I start with this 1 by 1 square and I increase it, dilate it by a scale factor of 3, all right? So the ratio of the lengths, all I've done is take this length, which is 1, multiplied it by a scale factor, multiply factor, by 3, 1, and now this length becomes 3 times more. And this length becomes 3 times more, all right? So the ratio of the lengths is simply, I got 3 compared to 1. 3 to 1, which turns out to be my scale factor in simplest terms, all right? So we have this very simple relationship, which is what the ratio is telling us. A relationship between lengths of things that get hit by a scale factor, all right? That the lengths simply increase by that scale factor. Very simple, all right? You wind up with a ratio of the new one compared to the old one that equals the scale factor when we're talking about one-dimension things. And we've talked about this as far as the scale factor of lengths is just the scale factor to the first power, all right? If we look at the ratio of areas in a scale factor, yeah, you're right, it would be the scale factor squared. What does that look like? Well, if I have my 1 by 1 square, it has an area of 1. Length times width, 1. And I increase this by a scale factor of 3, my dimensions went up times 3, but notice that the area now, 3 times 3, my area is now 9, and the ratio of the scale factors is 9 to 1, 9, which happens to be the scale factor squared. And so we talk about the ratio of the areas as the scale factor squared, okay? Finally, the ratio of volumes, you might suspect, yeah, is to the third power. If I take a cube now, 1 by 1 by 1, and increase it by a scale factor of 3, my dimensions went up times 3, my area went up times 9, but my volume now, since I have 3 dimensions, my volume now is 3 times 3 times 3, 3 to the third power, the scale factor, 27. And so my ratio is 27 compared to 1. And that 27 happens to be the scale factor to the third power. All right? It's this relationship we can use in problems like bricks. Well, let's say you got a small brick and you want it to be 50% bigger. All right? In other words, you're going to increase it by a scale factor of 1.5, 1.5. All right? So what's the ratio of the volume of the small brick to the large brick? And you may say, I didn't even tell you how big the small brick is, but you don't need to know because it's a ratio. All right? No matter what the size, it's going to simplify down to the same number because it's all going to get multiplied by the scale factor. And so we talk about volume. So the ratio, and we're going to call the small brick 1 because we're going to keep things simple. All right? So therefore, if the ratio, or if the volume of the small brick is 1, then the volume of the larger brick is the scale factor to the third power, 3.375. 1.5 times 1.5 times 1.5, and the ratio would be 3.375 to 1. All right? And so now we can use that to connect to other things, like if the smaller brick weighs 3 pounds. All right, we don't really care what its volume is anymore. Well, we want to know, is that going to be too much weight to carry around? What's going to be the weight of the new 50% bigger bricks? Well, that would be the original times the new volume scale factor, 3 times 3.375. And we would see that if the small brick weighed 3 pounds, then the 50% bigger brick is going to weigh over 10 pounds. All right? And that may be good or bad depending upon your situation. But at least you have something to know before you go out and buy bricks, right? So this is how you can scale things up. Scaling down would be the same thing, except you'd use a fraction. But it's all multiplication. All right? So that concludes our talk about scale factor. Hopefully this made a lot of sense to you. And you nodding your head, you're going, yeah, I knew this. And the word ratio is the only new thing here. Don't let it mess you up. Have a good rest of the week. Lesson 106, do A to D.